Okay, this is the introduction to trigonometry. And trigonometry is my favorite. You must know the first three main functions. And they are sin, cos, and tan. Alright, now remember it's a function. So let's do the bow and arrow again. Right. So in trigonometry, what goes in is an angle. Okay? This is your input. Now you're going to shoot something on your target. That is your y, which is your output. And in trigonometry, it is a ratio. So I have to explain to you what it is. So I'm going to use the tan function. So our input is an angle. Here is our angle. The angle is always positive if it goes anti-clockwise from the x-axis. Right, so I put this angle in. What is the thing I shoot on the target? It's the ratio. It's the ratio of this side over this side, which is the opposite side over the adjacent side. Alright, now 4 over 1, which is really 4. But what does it mean? It means 4 meter per 1 meter. So that is how tan is going to be with this angle. So if I draw the same angle, but I make this 2. Now remember, what does the tan of theta tells me? It tells me this. But how much do I have now in this side? I have 2. So if I want to know this side now, the opposite side, you can call it the height if you like, then I say, okay, with this angle theta, it is 4 meter for 1 meter of the adjacent side. But now it's 2. So it's 2 times 4 for 1, so it's 8 meter. So it's actually a ratio. It's like when you're going to buy Coke. You know 1 Coke costs 8 rand, say. Okay, so it's 8 rand for 1 Coke, and you buy 4 Cokes. So you're going to have to pay the lady 32 rand. And that is what trig is about. It's a ratio. What I'm going to do now, I'm going to show you 2 practical examples of where we can use the tan function. So say we have a problem. We have a tree there, and we want to get the height of the tree. Now you can't get to the height of the tree because the tree is too high or too difficult. So what you're going to do is, and my students do this as a project, you build a clinometer, which is like that. My students go and stand in front of the tree. They measure the distance to the tree. Let's say it's 10 meters. That's easy for them. They measure it on the ground. They don't have to climb the tree. And now they look with the clinometer and they go to the top of the tree. They get the rotation. And that's what an angle is. So you can see it hangs at 90 and you just get the difference. So they will have this angle of inclination, we call it. So how are they going to get the height of the tree? They're going to say the tan, okay, what did we measure? Say we measured 40 degrees. Remember, it's the opposite side over the adjacent. So it's h, and this is 10. So now I can figure out what is h, because h divided by 10 is this. So h itself is 10 times the tan of 40 degrees. And it is an actual fact, 0.84. So we get that, obviously in meters. Now remember, that's only that part because I was standing here, so I must also measure my own height. And if I measure my own height, or my pupil's height, or whoever did it, 1.8, if I want the height of the tree, I have to add it to this. Okay? And that will give me the real height of the tree. This is now the second example. Remember, the basic idea is that you either have the angle, then you can get the ratio, or if you have the ratio, you can get the angle. Now in the previous example, we measured the angle and we actually got half of the ratio, the other half of the ratio. Now, let's look at this practical example. You have a stick, and you're outside, and it throws a shadow. So I'm going to say the stick is so long, the shadow is 1, 2. Now the sun is shining, so it's shining like that. So this angle here, we will call the angle of elevation, and it's the opposite over the adjacent. So it's the tan of that angle is this. Now we have the output, we have the ratio. So if we have the ratio, we can get the angle. Now you do that on your calculator. I will speak about that later, but you get the inverse function. So your theta, in this case the theta is equal to 54.78 degrees. Now, say just after that, you go in, there's a lovely acorn tree. I can see through the window there is a lovely acorn tree in this beautiful garden. And you measure the shadow. Okay, so there is the acorn tree, and now you measure the shadow. Okay, so I'm going to measure the shadow, and the shadow is, say, 10.3 meter. Alright? Now, remember, it's the same time, the sun is still at the same spot. We will presume we did it very quickly. So this angle is now 54.78. And now you can work out the height of the tree because you've got the angle. So the tan of 54.78 is the opposite over the adjacent. So it's the opposite, we'll call it h, the height of the acorn tree. And therefore h, we just times by 10 on both sides. And you have the height of the acorn tree. I think it is 14.59. Alright, in trigonometry there's basically 6 functions. And the first 3, the sine, the cosine, and the tangents, you probably, I think you do it at school now, and the other 3 we do at university. But you should know what is all 6 of them. So let's look. This is our angle, and sine is now the opposite. It's a ratio is the output. It's the opposite over the hypotenuse. Alright? So the memory aid is that. Let's look at cosine. We just write cos. It's the adjacent over the hypotenuse. And the memory aid is car. Okay? And then tan. We've already done tan, so you should remember it. It is the opposite side over the adjacent side, and the memory aid is that. Now where is the others? The other one, sine, is just cosec of a, which now will be the hypotenuse over the opposite. Or, in actual fact, 1 over sine a. Cos is sec of a, it's the opposite, and tan is cot of a. It's just the inverse of that function. Remember I said with log, the graph tells us about the behavior of the function. So let's look what happens with the sin function. Y is equal to sin x. Input is an angle. What you shoot on the target is the ratio. This is what happens to sine. Can you see from 0 to 90 it goes up, it goes down, and this is the ratio. You can see the ratio goes up. It's 0 again at 360. So in maths we have the concept of the quadrants. 0 to 90 is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. Okay? Let's look at cos. Notice that sin is positive in the first 2 quadrants. If you put the angle between 180 and 360 in, it's going to be negative. Look at cos. Cos starts at 1. So if we look at this, it's the first quadrant, it's all the ratios are positive. The next quadrant, the ratios, the angle goes in, the ratio are negative. This is also negative, and that one is the fourth quadrant, and it is positive. So if we look at the graphs, and we draw the 4 quadrants, this is from 0 to 90, né? I said this is a positive angle to 180, to 270, to 360. You go anti-clockwise for positive angles. So you will notice that all the ratios is positive in the first quadrant when the angle is acute. In other words, less than 90. In the second quadrant, only the sine is positive. In other words, also cosec, cosec of that angle. In the third quadrant, only tan and cot is positive. And in the fourth quadrant, it's only cos and sec. So when I teach, we always say, all stations to Cape Town. That's how you remember what is the sign that comes out. The ratio that comes out will have a sign for each different function. Let's look at the function. That is the function. Now I explained to you the function has an inverse function where the input becomes the output becomes the input. So your inverse function is called arc sine. The ratio goes in, the angle will come out. Or, this is on your calculator, it says sin minus 1. When you want to find, they give you the ratio, you want to find the angle, you put the ratio in and you find the angle. Now for this inverse function to also be a function, you have to restrict the domain. So for sine, this angle can only be between 90 degrees and minus 90 degrees. Then it is a function, because otherwise you will get more than one angle that will give you the same ratio. So we restrict it. As a student, remember, you can't just write sin on its own. Because sin, to make sense, it must operate on something. So you have to put an angle there or something, and then you get the ratio. A lot of students write sine, and then I have to mark it wrong because there's no object. This goes together. You can never just write cos or tan. It must be of an angle. You're going to get, very simply, you're just going to get the following two basic problems. For instance, I'm going to say the cos of 60 is what? And you're just going to go to the calculator and the calculator will work it out for you. Now, say they give you this problem. In other words, they want the angle back now. They give you the ratio. Now you go first to the graph. 0.5 is a half. This is 1, this is a half. On the graph, you see this is an angle, and this is an angle that will shoot out a half. So there is actually solution, there's two solutions. Now, here I teach the concept of the butterfly. This is your basic frame of what you're going to do. So now you look at this, you see, from the graph, you see it's in the first quadrant and in the last quadrant. Remember this, all sin, tan, cos. Cos is positive, so it's here and here. And that's correct. It's the first quadrant and it's the fourth quadrant, right there. So we are actually, let's do it in blue. We are working here and here. Alright, this is the angle you have to get, and the other angle is that one. So how do you determine that? You go to what we call the reference angle, or the acute angle. So you go arc cos 0.5 is 1. Or, on your calculator, it will look like that. And it will give you an acute angle if you put in a positive. So you must always put in a positive ratio, and it gives you the acute angle. So in this case, it will give you 60 degrees. Alright, so your angle is there. So the angle x is 60 degrees, or the angle is here. This is the acute angle. It's always the angle it will make with the x-axis. So to get this angle, we just say 360, which is a full revolution, minus 60. And there we have the answer. Here is another trig equation with signs. Sine of x is 0.342. Let's look at the graph. This is the ratio, it's under a half. I can see there are two angles. The one is in the first quadrant and the other one is in the second quadrant. Now remember, all sin, so it's here or there. So there you've got your butterfly. Now, the first thing is to get the reference angle. So you go on your calculator, sin minus 1, this ratio, and you want to know which angle is that. And it gives you 20. So you got the acute angle. So now, you fill in your acute angle, and you have this angle and that angle. Will give you a ratio of that. So your answer here is 20 degrees, and in this case it's 180 minus 20 is equal to 160. Now try and do the trick problems in the maths cards for inspiration, and you will pick up a lot of knowledge. Thank you.